Hey guys, this is Mr. Grice for Algebra 6.4 Notes. Today we're talking about applications of exponential growth and decay. Our learning target today is to be able to apply the simple growth and decay formulas to real-world situations. So as you can tell, I already have the two formulas written down, but before we really get into it, let's talk about the differences, okay? So remember that y equals, you can write this on the top for growth, a, and it's 1 plus r over t, okay? So this is for growth. Well, let's talk about what those letters mean real quick. I'm getting ahead of myself. So for this, the a equals the starting amount. What you start with. It could be money, it could be people, bunnies, it could be tons of different things. Okay, we're talking about the application, so it's going to be a lot of word problems today. Okay, R equals the rate, and we need it as a decimal. Okay, and the T stands for time. Okay, so if we had a problem where they said that y equals, let's just say 1 plus 0.03. Okay, and then we've got the t, right? Remember that this right here is addition. This up here is a variable, okay? So when you combine like terms, we'll get a number in there in the middle. And is that greater than 1 or is it less than 1? Okay, it is greater than 1. That's our base. So the base is greater than 1. That's important to know because right here it says the base is always greater than 1. Okay, you need to look at the base. Okay, now all these letters, all of them mean the same thing. Okay, A is your starting amount, R is your rate, T is your time. So if we're doing this again, but now we're doing decay, let's just use the same number. 1 minus 0.03. Now, if you want to use your calculator, go right on ahead, do it. Okay, whatever helps you get the right answer. But if I have $1 and I take away 3 cents, I have 97 cents. And you can put the 0 there to help you remember. Okay, but when we have a decay, our base, that center part, is greater than 0. Oh, hold on, we wrote it somewhere else. It's greater than 0 and less than 1, but it is between 0 and 1. Okay? Most people say, oh, it's a fraction. It can be, but it's going to be a decimal between 0 and 1. All right, now, since we're doing word problems, we need to remember some words that represent these growth and decay. So the words that came up in class, if something grows, if it increases. If you think of a balloon can inflate, get larger. Okay. Those are the ones that we're going to be talking about in our lessons today. There are, of course, always more. Words that mean decay. We have the word decrease. Something gets smaller, it can shrink. We heard the word depreciate. Normally that's talking about money. Your money depreciates, or the opposite of inflate is deflate. And those are just some examples of words that you're going to be seeing. Okay? Now, let's get into an example. So it says to use the appropriate formula to answer the application problems below. In 2006, teen spending totaled about $79.7 billion and was expected to increase by 3.5% every year after that. So let's see. We got some money right there. We've got a percent. And now, is this talking about growth or is this talking about decay? There's our key word right there. This word tells me we're talking about growth. Okay, so I know this is the formula that we are going to be plugging into. Now, off to the side, I need to know what my A is, what my R is, and what my T is. Now, the A is the amount that we start with. We are starting with $79.7 billion, so 79.7. Now, my percent is 3.5%. All right, so when you've got 3.5%, you can do two different things. You can take 3.5 and divide it by 100, and you'll get your answer right away. Okay, so I'll do that with you guys. 3.5 divided by 100, and we get 0.035. Or, if you know, dividing by 100, you're really moving the decimal 1, 2 times, and you add a 0, and then you get 0.035. So whatever way helps you to remember, that's what you need to do. But 0.035 is the number that we need. Okay? And for time here, since we're just setting up the equation, we don't know what the time is yet. Okay? So let's plug the numbers in we know. We know 79.7. We're using the number 1 plus 0.035 times t. And what we want to do is we want to combine our like terms. And now we're going to have our complete formula. 7.97. And if you need a calculator, 1 plus 0.035, do it. And there we go. This is our equation that we're going to need. Okay? And does it represent growth? Well, look at this. Look at your base. Is it greater than 1? Yeah. So that means this is our growth equation. Okay? Now, what was the approximate teen spending total for 2013? Okay, so once again, we know that it's 79.7. We know that the rate is 0.035. That's all the stuff. The only thing we really need now is the time. Okay, so I'm just going to plug in all this because this stays the same. Except now I need that number there. You're not plugging in 2013, guys. This is where you need to read and think. Okay, this is starting at 2006, and now it's 2013. How much time has passed? If you need to go off to the side and subtract those numbers to figure it out, or use your fingers, do what you got to do. But it's the number 7, okay? And now that we've got that, we can plug everything into our calculator. We have 79.7 times, in parentheses, 1.035 raised to the 7th power. And then you should get your answer. Okay? Now, when we're rounding, I'm sorry, that was 101.400. When we're talking about money, we want 2 decimal places. Okay? But we need to round in some of these situations. If you've heard 5 or more, raise the score. 4 or less, let it rest. Okay? In this situation, it's a 0. So whenever we round, we're going to put the squiggly lines there because that's telling us that we are rounding our answer. We're talking about money, and it's 101.40 billion. Okay? You teenagers are spending about $101.4 billion in shopping. Pretty crazy, huh? Don't worry, it's not just you. At least I hope it's not just you. All right, let's look at Daniel's print shop. They purchased a new printer for $35,000. The value of the printer depreciates at a rate of 5% each year. So is that growth or decay? By looking at your keywords, you should be saying, Mr. Grice, it's decay. So I'm just going to write the original equation so we remember what we're doing. A is 35,000. Our rate is 5%, and 5% as a decimal is what? 0.05. And we don't know what the t is yet. So here we go. Y equals 35,000, 1 minus 0.05 t. Okay, 1 minus 0.05. If you had $1 and you took away 5 cents, you would have 95 cents. Okay? And there's our equation. And now from the equation, we're going to go through and solve, and it tells us to solve after the printer's been used for 4 years. And did you guys know that after time goes on, your technology decreases? Well, think about the new iPhones. Right now, they're an iPhone 5S. The iPhone 4S, that is no longer worth $650. Okay? After 2 years, the price of that went down because newer models have come out. All right? So let's go ahead and do the equation. We get y equals 35,000 times 0.95, and our years are 4. Okay? So just plugging that into the calculator, 35,000 times 0.97 raised to the 4th power. Or not 97, 95. Raised to the 4th power. Okay? And remember, we need to round that. So that was 28,507.518. So 51718, sorry. Okay, so when we're rounding, we have to look at the next number. 5 or more, raise the score. 4 or less, let it rest. So $28,507.72. If you need help with the rounding, you need to come in and see Ms. Carranza or myself to help you out. Okay? All right, let's flip it over. All right, number 3 says a population of 20 rabbits was released into a wildlife region in 2007. The population grew at a rate of 200% every year after that. Estimate the population of rabbits for the year of 2018. All right, so what did we start with? Well, we started with 20 rabbits. Our rate of 200%. Now remember, if you need to do 200 divided by 100, that was one way we said you can get your answer. And you get 2. And the last thing we need is the time. Okay, our time was from 2007 to 2018. Okay, so 2018 minus 2007, you should get 11. Now, is this going to be growth or is this going to be decay? Keyword, grew. So we're going to be using the growth formula. Okay, so y equals, we're starting with 20. We have 1 plus 2, and we've got 11. Okay, let's simplify the inside first. And now let's find out what our answer is. So if you started with 20 bunnies into the wild, what do you think you'd get? We know it's going to be more. What? Do you see how many rabbits you're going to have? After 11 years, you would have 3,542,940 rabbits. Isn't that insane? It's true. Rabbits reproduce very quickly. Whenever a mama baby or mama bunny has her baby, she has like 6 or 7. It's insane. Okay? It's true. Ask your history teacher. All right. Number 4. You drink a cup of green tea that contains 27 milligrams of caffeine. In an average teen, the amount of caffeine decreases at a rate of 9% from his or her body every hour. How much caffeine would you have in your system after 4 hours? Well, is this growth or is this decay? It's decay, okay? So our A is 27 milligrams. Our rate is 9%, which is 0.09. And our time, they straight out tell us, is 4 hours, okay? So y equals 27, 1 minus 0.09 times 4, or to the 4th power. 1 minus 0.09, if you have $1 and you take away 9 cents, you now have 91 cents. And let's go ahead and plug that in. We have 27 times 0.91 raised to the 4th power. And when you round this, I'm just going to round it here. You look, we have the 1, we look at the 5. 5 or more raise the score. We're rounding to 0.52, and that's milligrams of caffeine. All right, last one. It says Jalen deposits $500 into account whose value inflates. That's a keyword. We said deposits 3.5% each year. How much money will Jalen have after ... growth or decay? Good. Growth. So let's go straight into our equation. We know that we're starting with $500. 1 plus 3.5. Well, that was what we used earlier, so it's 0.035. And then our first one, we're saying in 10 years. Okay? So after 10 years, if you put $500 into your account, how much would you have? After you add those numbers up, let's see what we get. So you have 500 times 1.035 raised to the 10th power. Round it, what do you get? remember you're talking about money, she gets $705.30. Okay, once again, if you're not rounding correctly, you need to come see Miss Carranza or myself. Okay? All right, letter B, you're all on your own. Go ahead and pause the video and good luck. Remember, you're still using the growth formula. It's just that your time is different. Okay, and you should get y is equivalent to $1,666.80. Did you guys know that if you leave your money in a bank account, you get interest on it and you get more money? That's why it's important to start young. Okay, now your homework is at the bottom, 6.4 practice. Now, you have a test coming up on Friday. So if you need help, you need to come in and get it. All right? We'd love to help you out. That's our job. Okay. Well, this is it for Algebra Unit 6.4 notes. Thanks for watching.